Alright, welcome back. So today we have a problem from the most recent ELMO, which I don't know if that has been graded yet, from what I've heard. But yeah. So n is fixed and you want to find the number of sequence. What is this condition? So for every k, wait, huh? Okay, so for every k and all non-negative integers m. Okay, so something's I don't know what's going on. Let's just do n equals 1. So like what is this saying? When n equals 1, I need to set a0, a1, a2 such that there's two conditions. The number, wait, no, m is like anything. This is like okay, so a0 has to be 0, right? Like, because you pick if you let m be very large, what you get is, so from k equals 0, a0 has to be equal. Wait, now I'm really confused. Oh, yeah, no, a0 is just 0. That's fine. Okay. And then for k equals 1, this is saying that in a1 and a2, I have every number between 1, 1/2. So it's weird because like m is not bounded, which is like okay because the numbers just go to infinity. But for n equals 1, this is saying a0 equals 0. That's the first statement. And a1, a2 need to have 1 and 0 in them. So there's like two sequences. There's 001 and 010. Oh, that's fine. What about when n equals 2? So a0, a1. So this is the first time the sequences actually intersect. And the condition is you need to have 0 in here, and then you need to have 0, 1 in here, and then in here, in the last, for k equals 2, it's like 0, 1, 2 need to all be there. Which is okay, but I feel like at this point I want to try a bigger case, because I'm not sure how much I'm learning from the small ones. But for this one, I guess, I mean, a0 is still 0, and then pick a0, a1, a2, however you want, and then a2, a3, a4, you slap the other numbers in. Because they're not interlocking enough yet, so I'm not seeing. So let's just do a really big n. Let's do like n equals like, what's a big number, guys? 7. Actually, let's do 8. I feel like I want to do a power of 2. So for 8, there's going to be 8 conditions, or 9 conditions, right? 2, a3, a4, a3, a4, a5, a6, and it goes all the way. Oh, jeez. Okay, whatever. We'll just write it. I think one interesting thing is like you have this. You actually have a nested fractal thingy, right? Where, sorry, that's a terrible use of the word. Every sequence that's valid, like when I increase the value of n, the only thing that changes is I add new rows to this table that I'm making. No. Okay, so 2, 1, 0. So 3 is the one. So when I take 3 and I cut it in half, I get 1, and then 0. And then for 4, it's like 0, 1, 2, 4. So okay, maybe I should start with n equals 4. I think n equals 4 might already have something interesting going on. Actually, let me do n equals 5, because I want to see what happens if. I think 5 feels like it's more like it's tacked on. So 5, 2, 1, 0. Okay, so there's definitely some binary type thing going on. Okay, I never like really doing this, but I will actually write down what the answers are, just to help check my work. So here the answer is 2, right? For n equals 1. Here the answer is, so this is 0. You do these however you want. You stick on the other 2. This one's 4. And the circle 2 looks exactly like a 3, so I will write it properly. 2 circle. And the reason I do that is because like when I look at this, for example, this A9, A10, when I tack on something to like one of these numbers has to be 5, and then the other can kind of be whatever it wants, almost. Because A5, between A5 and A9, very likely all of 0, 1, 2 appear. By which I mean... Actually, that might not be completely true. The other thing we haven't seen... Maybe I shouldn't have jumped straight to n equals 5, because I don't know what it's because... Up until n equals 2, we never had, like, truly free numbers. But here we kind of do, like in this n equals 5 example, A9 and A10, like one of them needs to be 5. Wait, hang on. I think I'm clowning. Wait, something's wrong. Something's wrong. N equals 3 is actually quite different. N equals 3 is the first time where you get free choice, right? Okay, let me actually do n equals 3 also. N equals 2... Wait, I think I'm... Hang on, I'm actually just messing everything up. 1, 2, 3... n equals 3 is actually quite different from n equals 2, so I better actually do n equals 3. Because when n equals 3, for the first time you have like one of these rows. N equals 3 is the first time where you have a row where there's like more blue numbers than red numbers. So n equals 3 looks exactly like n equals 2 to start. But you also now have A3, A4, A5, A6. And then, okay, so what are the things? We need 0, 0, 1, 0, 1, 2, and then 0, 1, 3. So one of the numbers needs to be 3, but what do you use to write? This is a Wacom tablet, looks like that. It's a little pen. Courtesy of 0x Park, who gave it to me as part of a reading group. In general, if you want to see... Actually, I don't remember if I listed the tablet that I'm using. But most of my setup is here, if you want to see that. Just drop the link in the chat. Yeah, the tablet is actually not there. I should write the tablet. But... Right, what was I saying? So, you know, everything up to here is fine. And then A3, A4, like... One of them is missing... One of them is 2. And the other is missing... A3 and A4 kind of aren't any different. So I can fill those however I want. Okay, let me actually do this. So A0 is 0, that's fine. A1, A2 is... 0 and 1 in some order. It doesn't matter which, I think. Then, so we'll just say 0, 1, and then there's a factor of 2 here. This is 1. 2 goes somewhere, 0 goes somewhere else, and there's another factor of 2. Again, it doesn't matter which one you pick. Now here, oh. No, it totally does, because the 1 is, Shiba. Oh god. Okay, so I can't just... Oh, lord. Okay, let me think this through. I'm reading a condition error, so it's AK through A2K, and then I need to have K and then every number that's some factor of 4. Okay. You know, I feel like we should have just not had A0. There's no reason. A0 only appears once and it's just bait, right? Like, it doesn't appear anywhere else. It's equal to 0. It doesn't affect anything. So, it feels like you could have written this statement with just A1 through A2 and might be a little... Whatever. I mean, it's fine. We'll just not pay attention to A0. I'm more interested in what happens afterwards. So, okay. Now, I'm going to at least get the answer, because I feel like at this point I don't even know what the answer is for n equals 3. So, okay. There are actually two cases. One is that in this case where I have 0, 1 here, if I have 0, 1, then this is 1, and then these are 0 and 2 in some order. So there's two cases here, and then I need to have both 1 and 3. So these can switch, and these can switch. So there's 4 things here. And then case 2 is the other way, where this time instead of 0, 1, I have 1, 0. So 1, 0 carries here. Here's the 0 for A2. And then 1 and 2 are in some order here. We don't really care which order. And then now, one of the numbers here has to be 3, and the other can be whatever it wants. So that's actually a lot of cases. So I have 4 choices just across the board, and I could put anything for which there's at least 1, 3. So I think it's this. There's 14 cases here, so the grand total here is 18. The heck? Is this one really 4? Am I doing this right? Yeah, this doesn't feel good. Like 2, 4, 18 doesn't... This case is too different from n equals 2 or something. I don't know. Am I doing this wrong? I feel like I'm doing something wrong. Can we see the prompt statement? Yeah, it's this thing. Okay, what did I do wrong, guys? Help me out here. Oh shit, I forgot about the 0. Mother... Shiba. Yeah, sorry, I forgot there has to be a 0 in the bottom. Okay. Never mind. Everything's okay. Yeah. Okay, so let me actually write stupid. So 0, 2, and then we need 1, 3. In the case where it's 1, 2, I need 0, 3. Okay, never mind. Crisis averted. This feels more controlled. 8. Like this one's 1, 2, and this one's 0, 3. And not only that, it's like it's a clean power of 2, in the sense that every choice of sequence for n equals 2 split off into exactly 2 cases for n equals 3. So now, well, we have a Christmas miracle where every row just always adds exactly a factor of 2. If that happens, then this problem's amazing, because it doesn't look like that at all from the condition. Also, that would be great because that would mean I'm done. So that's another reason we hope this is true. Yeah. So n equals 4. We imagine we have everything set here. And then we look at A4, A5, A6, A7, A8. And n equals 4. I feel like this might be too optimistic. So, okay. If I only really need to look at the possibilities for the last row, right? Because that's really the only thing I like. Rows have shelf life of 2. Maybe that's what I should say. Like once no, it's not shelf life 2. It's no, it's shelf life 2. Like if I know A3, A4, A5, A6, I don't really care what any of the other things before that were. So I'm gonna make a list of like the last rows that can happen. Let's do that. So we're gonna zoom out a tiny bit, and then I'm going to write last row. Because if I know the last row, that's all I care about. So here, the last row is either 0, 1, or 1, 0. Here, the last row is what was it? Shit. What is it? Anything that ended with 2 in not the first position, right? And then 0, 1, 1, 0, 0, 1, 1, 0. And then for n equals 3, the last rows we found were all permutations of 0, 1, 2, 3, I think. And specifically, I have them written, right? So it's like 0, 2, 2, 0, 0, 2, 2, 0, 1, 3, 3, 1, 1, 1, 3, 1, 3, 3, 1, 3, 1. And in the other case, it swapped around the other way, where this was 1, 2, 2, 1, 1, 2, 2, 1. And then we had 0, 3, 0, 3, 3, 0, 3, 0. So now I have a new number called 4 that needs to appear, and I'm like cutting off the... Relative to this, I'm cutting this off, and then I need to add 0 and... I need to add 4 and some other number. And 2 is always in there. So I think, yeah, this will be like, you know, you either throw on 4, 2 or 2, 4 at the end. Here it'll either be 4, 2 or 2, 4 at the end. Okay, so I think at this point, this is actually just what's going to happen, and all I need to do is give a good description of what the last rows are. Right? Like basically the claim is that given the valid sequence for n, there's exactly 2 ways to extend it to n plus 1, and it should involve like ping-ponging between 2 different numbers. One of which is 5, and then one of which... Okay, so what do I want to do? So when I introduce the number 4, like my generic sequence in this thing looks like like, for example, this one or the other one. Shoot. No. 0, 1, 3, 2, 4. Or the vice versa. I think what's happening is the numbers are moving from left to right at exactly the right speed so that when you reach a chopping block, yeah, like the property that I need is that when I'm adding on 5, for example, then all of 0, 1, 2, 5, like the left should all be 0, 1, 2, 5. And I think that's going to happen. And I need to work out why it happens at exactly that time. Actually, no. I think that's just true. No, actually, is that obvious? I can see what's happening with the 4, which is that, I'm inserting the 4 here in either the 4th or 5th position. So the first time that the 4s reach the chopping block, like the far left, will be either 3 or 4 turns later, i.e. at n equals 8 or n equals 9, which is exactly when that 4, you want that 4 to be on the end. So yeah, like this is just gonna this is what's happened. I need to think about the other things I'm adding. Like for example, well, 0 is always there. Is 2 always in the chain? 2 is not always in the chain. Oh wow, this is very well said actually. 2, 3, 1. Hang on. Let me do this properly. We're gonna actually write out all the cases for what happens after this. So 2, 1, 3, 0, 4. And then 0, 1, 3, 0, 1, 3, 4, 2, 2, 4. And then the same thing with 3 and 1 swapped. And then the same for here, where now it's 2, 0, 3, 2, 0, 3, 1, 0, 3, 1, 0, 3, 2, 3, 0, 2, 3, 0, 0, 3, 0, and then again the point is that whatever number got chopped off is in the trajectory of 4, or 4n equals 4. So it's like 4, 4, 2, 2, 4, 4, 4, 4, 1, 1, 2, 2. So why does this line up so well? Yeah, let me actually write labels, right? So the thing was like A3. So this is A4 through A8. Yeah, I guess the thing because I'm only writing the last row, I might be forgetting some information. But I don't know. Like, so what was the thing that was deleted? Like 0. Well, it's whatever number. This is what A3 was, right? And then, yeah, so like right on time when I read A4s, it's like 0s and 2s. Oh, okay. Okay. Like the point is whatever A8 is, or whatever A7 and A8 is by... Okay, okay. Like the A7, A8 things, when I add this thing, are by definition the trajectory of the number 8 under repeated division by 2. So then, for example, when I go to 9, 10, and it's like 5 to 1, like the numbers by definition I'm adding are... Yeah. So the point is that, like... Okay, here, okay. I think this is what I want to write. And it's almost obvious now that I'm looking at it. So like the point is claim the A2k minus 1 pair, A2k pair, are like in the set 2k, or just k, sorry, just k over 2 to the m. And then A7 and A8 don't reach the chopping block until we are looking at A15. And they don't reach the chopping block until we get to the number that makes this all work out, namely A16, I think, which is exactly 4 things later. So that the timing works out exactly right, and it's always this bifurcation. I think that's it. That's actually just the solution. It's just... No, come on. This is fine to write up. I don't know what you guys are all whining about. I'm gonna eat those words because I'm about to write it up. Okay, anyways, yeah, that is a full solution though. So yeah. So yeah, for those of you on YouTube, we'll probably just end that here. Thanks for tuning in, and see you all next time.